Now let's see why we use concrete with rebar instead of just concrete. Concrete does very well under compression since it has strong adhesive forces, and the compressive forces just add on to those adhesive forces. However, in tension, concrete cracks easily, and that's because it's non-linear and non-elastic, and the tensile forces are in a direction opposite to that of the adhesive forces. But why do we use steel so widely in rebar with concrete instead of another material? Steel does very well in compression just like concrete, so it doesn't take away from the positives. In fact, it adds another positive, which is steel is also very good in tension, unlike concrete. Steel seems to be one of the cheaper alternatives to other metals or other substances in general that can be used with concrete in a rebar. Now let's see a more mechanical example of why concrete is not as good as concrete in a rebar. Here we have a bar of rectangular cross section. The dimensions are 16 is the height and 8 is the breadth. This is just concrete. The modulus of elasticity for concrete is 3 × 10 to the 6 psi, and the maximum compressive strength that concrete can withstand is 1350 psi. We want to find the moment of inertia about the z-axis. The formula for that is bh cube over 12. Substituting the numbers in, we get 2730.67 psi. Now, the formula for compressive stress is moment times centroid over I sub z. Making m the subject of the formula, we get moment equals 1350, which is the compressive stress, times I sub z, which we just found, over the centroid, which in this case is 8, since this cross section is a rectangle and the centroid of a rectangle is just 8, or half the height in this case. The answer works out to 460,687.5 pound-inches.